So looking at geometric distributions, here's what we know about them is they are very similar and kind of in nature and makeup to a binomial distribution, except that there's a one difference. So the one difference is that in a binomial, we have a fixed number of trials. In geometric, we can do an infinite number of trials. But really what we're after is how many trials until we see our first success. Okay, so let's see if I'm going to point out that something is in fact geometric, instead of bins, I'm going to be looking for bits. So B, binary, I, independent, S, success for every single one. So the difference here is T. And so what we're going to say, instead of a fixed number of trials, we are going to do trials until success. Okay, that's the difference. Remember our good old pal binomial is bins. And so the difference there is the numbers of trials are fixed. Here, we can let the trials go on forever until we find our first success. Okay, so check this out. Let's talk about, okay, well, what does that actually look like? So let's do this. Let's go back to like a basketball problem, right? So basketball, let's say we're talking about that free throw shooter again, or some free throw shooter, free throw percentage, and somebody is, let's say they're a 70% free throw shooter. Okay, so here's what we need to know. We just need to know the probability of success is 0.70. Now, I'm not going to fix the number of trials. Now, the question would probably be something like, what is the probability that we see the first success on the 8th free throw attempt? Or what is the probability that we see the first success on the 3rd free throw attempt? Something like that. So let's start real basic. Let's say, what is the probability that I see the first success, X, on the 1st attempt? Well, you know how you do probability? It's multiple trials, so it means multiply. So that means on the first, I went right out and I saw 0.70. And then I'm done because I'm done. I found my success. So what is 0.70 times nothing? Or times 1, it's 0.70. So there's a 70% chance that this free throw shooter goes out and makes the first free throw on the first attempt. Okay, that makes sense. Let's try this. Probability that X equals 2. What does that mean? That means that we saw the first success on the 2nd shot. So what does that mean about the first shot? That means you missed it, and there's a 30% chance that you missed that first shot, and a 70% chance you make the 2nd shot. So if I did 0.3 times 0.7, I get 0.21. So there's a 21% chance that I make the first free throw on the 2nd shot. Okay, that makes sense. Let's do another one, right? So we can kind of get this idea. What about the 3rd shot? Well, what has to happen on the 1st shot? Well, it means we missed it. What happens on the 2nd shot? Well, you missed it. What happens on the 3rd shot? You made it. Okay, so let's go 0.3 times 0.3 times 0.7, and I get 0.063. So there's a 6% chance that I don't see my first success until the 3rd shot. So again, what are we looking for? First success. I'm always looking for the first success. What shot does that come out on? So let's do one more just for fun, right? X equals, how about we go 0.30 to the 3rd power, because I'm going to see 3 failures, and then finally I'm going to see a success. Okay, that seems doable. Let's do that to the 4th power, and then times 0.7. Okay, so that looks like 0.00567. Wow, we are getting really small all of a sudden, right? But think about it. It's a 70% free throw shooter. And so what is the probability that they're gonna miss and then miss and then miss and then finally make it, right? They're a 70% free throw shooter. We expect them to make it a lot sooner than that. So what is the common thing for geometric? The formula, probability that X equals some K value. Well, guess what it is? It is the probability of failure. That's what's going to happen first. How many failures are we going to see? We're going to see K minus 1, right? Because if K was 7, then K minus 1 would be 6. I see 6 failures. And then probability of success. This is it. There it is. There is your formula for a geometric probability. This is the probability that, that's the probability of an exact number, to find its success, right? So that's it right there. So sometimes you get problems like this though, right? They'll say, what is the probability that x is less than 4? So can you interpret that for me? You know what that actually is saying? It's saying what is the probability that the first success came on the first shot, or the first success came on the second shot, or the first success came on the third shot. And that's it, right? That would be less than 4. So the first success came on some shot before 4. Well, just calculate this, and then calculate this, and then calculate this. Well, if I was going to do that, that's going to be 0.7 plus 0.21 plus 0.063, right? That would be the answer there. So we can find that right there. So that is the probability that it's less than. What if I said this? What's the probability that x is less than or equal to 4? Well, that means that it's on the first shot, or the second shot, or the third shot, or the fourth shot. So now the fourth shot is available to us, right? So what do? It's going to be the first one, or the second one, or the third one, or the fourth one. Add them all together. You get it right there. Okay, so these are hopefully coming together pretty nicely for you. Let me give you another situation. What's the probability that x is greater than 4? Greater than 4. Well, that's going to be probability that it came on the fifth shot, right? Greater than 4, or the sixth shot, or the seventh shot. Wait, how many shots are available? Right, because we're not fixing the number of trials. This is going to go all the way up into the infinite shot. Whoa. But the problem is the probabilities get so small way out here that actually it's not going to worry us too much. But how do I calculate that? Well, let me give you an easy way to calculate. What if I said that the probability that x is greater than or equal to 4 is 1 minus the probability that x is less than or equal to 4? Does that make sense? It's the complement of being less than or equal to 4 would give me the probability that it's greater than 4, right? Because that's what it's got to add up to. So let's try that. That's going to be 1 minus the probability that x is equal to 1, or probability x is equal to 2, or probability that x is equal to 3, or probability that x is equal to 4. Complement that. Whatever that is, complement it, and it will tell you how much is greater than 4, right? Because so the way that you do complements, you always think about, what is it that I don't want? I don't want up to and including 4. Complement it, and it's going to give you everything you do want, right? So that's how that would work right there. And let's put that together. Well, what do I do in my calculator? So in your calculator, you got two functions. One is called Geomet PDF, and you just need two things. You need the probability of success and when you want to see your first success. And then you got Geomet CDF. You just need the probability of success and what number you want to go up to. All right, when do we use what? Well, remember, just like binomial, the PDF is for an exact. And then CDF is for cumulative, for up to and including the K number. Whatever that K number, whatever it is you plug in there, it's going to calculate up to and including the K value, right? So let's try this real quick. Watch this. I'm going to go Geomet PDF in my calculator, and I'm going to put 0.70, that's my probability of success, and the probability that they get it on the third shot. So that's under my distribution tab. So let me put that up here for you. distribution tab. So go distribution, scroll on down until you find Geo. Okay, there it is. Geomet PDF. Probability of success 0.70. The X value, that's really the K or the X value, that's going to be 3. Paste it in there, and I get 0.063. Wait a second. That's what I got here. Well, yeah, it is, because this is doing the same thing, right? So this is the calculator function that'll get you that right there. Right? Super good. All right, let's do this. Let's go Geomet CDF 0.703. Let's check what that does. So distribution, scroll on down to Geomet CDF, got it, 0.70, put my X value of 3, and paste that thing in, and it's 0.973. Whoa, that is crazy bigger than this one. Why? Because it's cumulative. It's when do we make our first shot? This is saying that we make our first shot on at most the third shot. So on the first or on the second or on the third. So it is literally taking these 3 and adding them together for us. So Geomet CDF is the same thing as the probability that X is less than or equal to 3. That's what it's calculating for me. What if I wanted this, the probability that X is greater than 4? Well, I said, here's what I would do. 1 minus the probability that X is less than or equal to 4. So how do we chalk this up in our calculator? Well, it's going to be 1 minus Geomet CDF, and I'm going to put 0.7, and I'm going to put 4. That's going to get me the answer. And that's going to be the probability that he makes his first shot on anything after the 4th attempt, which should be pretty darn small, if I'm not mistaken. Let me actually just do that real quick in my calculator. 0.7, I'm going to do a 4 CDF on that. I'm going to go 1 minus that. Oh, yeah. Here's what I get as an answer. I get equals to 0.0081. There's a very little chance. As a matter of fact, somebody might even say that rounds to 0. There's almost a 0% chance that a 70% free throw shooter would make their first shot on the 5th or the 6th or the 7th or the 8th or the 9th or the 10th or all the way up to the infinity value, right? There's almost a 0% chance that happens. Should make sense to you. Okay, last thing I want you to know for calculation's sake is, how do you find the average of a geometric? Geometric average is also known sometimes as the expected value. So it is a pretty simple. It is 1 divided by the probability of success. All right, let's do it on this one. So let's see if I did the average of making his first shot, or the expected value, 1 over 0.70. So let's do 1 divided by 0.7, and you get 1.42. Actually, 1.43. 1.43. So a little more than 1 shot is when I expect. Wow, that's not how you spell expect. Expect to see the first success. On the 1.43, now it's an average, it's over the long term, so it's not going to happen on 1.4. So I really would expect to see the first shot made on the first attempt or the second attempt, because that's where we're kind of between. All right, there you go. Those are the formulas you need. Have that right there. We're not going to do the standard deviation of the geometric, though we could. I just don't. AP doesn't really use it very often anymore, and neither do we use it really at PCC, because this number is more important to us. When do we expect to see that first shot? It helps us to kind of generate good analysis, right? So if somebody's a 70% free throw shooter, when do I expect them to make their first shot? On the 1.4 shot, right? So that's kind of what that means. That's what that stands for us. So just remember that the difference between geometric and binomial: geometric is bits, trials until the first success. Binomial is we fix the number of trials, and I'm trying to see how many successes I can get within those fixed number of trials. All right, there's your formulas. So let's clean it up and let's do some work with it.